Welcome to the another session in Frontiers in CFD. So today's topic is CFD simulation of lithium-ion battery pack with fiber submerged in a water bath. So the first objective is to prepare the geometry of lithium-ion battery pack with fiber to generate the high quality computational mesh and apply the name selection on computational domain to apply the boundary conditions and visualize the results in the post processor. So this is the reference geometry that we are going to follow, and accordingly we will prepare the simulation for the same. So welcome you all to another session on Frontiers in CFD. So today we will see the CFD simulation for lithium-ion battery packs with the fiber which has been placed. So we are following one of the research paper which is shown here. So this is one of the reference research paper which we are going to follow. In that research paper it has been shown that this is a water bath, and within that water bath the fibers are in there, and there is one top channel and bottom channel, and we have the lithium-ion battery, and further it is subjected to the flow of fluid from inlet to outlet, and accordingly they have done some various combinations. So these are the various combinations they have done. We are slightly doing some different way as per the diagram here. So we are following, this is one of the diagram which is for the paper. So let's proceed. So to start with, we need to start with the workbench window. So click on the workbench. So we need to prepare the sketch, and then accordingly we'll proceed further. So those fibers are actually partially filled, partially in the fluid that is in the water bath as per the diagram which we have seen in the paper. So we'll try to prepare the geometry accordingly, and we'll visualize how the fluid flow will takes place and how the lithium-ion batteries are subjected to the temperature. So let's start with the fluid flow fluent. Go to the geometry, create new design modular geometry. So first of all, set the units. So I will set the units to millimeter. Click on any one of the plane. So what I will do, I will prepare a primitive, that is a box. Now as per the dimension which you are going to follow, 34 by 160. X will be 160. Z will be equal to 34. This one I will take it 75 because there is water bath is also present. So I will take the diameter of the battery as 18 and the height of the battery is 65. Few of the portion I will keep it for the water bath, and accordingly will proceed. So instead of add metal, I will make it add to frozen. So this is how the channel which has been generated. Now I will create one more plane. This plane I will generate it from the face. So this is the face I am going to select, make it apply, and let's click on generate. So this is one of the plane, and the face has been generated. So we'll follow this what is here uh, in the diagram, and accordingly we'll proceed. So this is the circle of diameter 18 at a distance of 16. This is a circle of diameter 3 at a distance of 4 from top and 16 from the other end. So we'll preferably follow the sketching operation here, and we'll go with the sketching, draw a circle. So first of all I will draw a circle of diameter 18. So here I have drawn a circle of diameter 18. So I need dimensions of the circle. From this should be from this. This is your 16 as per the specification. Same way, if you say this and this should be also some distance. So as per the diagram I am going to follow as 17. So put the value that is equal to 17. So this is one of the sketch which has been prepared. So we need circles over there. So 1, 2, 3, 4 and 5. So total 5 circles are there. So accordingly we are going to prepare the sketch. You can actually start with drawing these 2 circles also, and accordingly you can go ahead. So this is one of the way of proceeding, or you can simply uh, first draw 5 circles and then also you can do the operation. So both of it can be done. So preferably I will draw one more circle here. So let's say here, or you can do is you can just draw a line, because you know a distance over here. So what is the distance here from the center of this? So this is 17. So 17 minus 4, so that will equal to 13. So you can take the distance, this is equal to 13. So this dimensions to be equal to 13, and you can be in position to draw 2 circles. Similarly, one more circle we can draw it here. So that is dimensions will be equal to 13. So put it 13. So let's draw 2 circles of diameter that is equal to 3. Okay, so put it diameter 3. Similarly, I will draw a circle on the other side. Okay, so this is also diameter equal to 3. Now we know this distance. So this, from this to this, the distance is 16. So you need to draw 3 circles, 3 more circles. So here I will just draw a horizontal line. So dimensions here will be equal to 16. So that will give me the circles now. Here also you can draw some line here horizontally. So dimensions will be again equal to 16, and one more dimension that is from the bottom. So this also will be required, that is equal to 16. Okay, so these are the 3 16s which we are drawn. Then draw a circle again of same radius which we had. Okay, so these are the 3 circles which have been drawn. Now what is required for us is to know the distance between the 2 centers. So this is the distance between this is 1648, so it will be 32. So I will draw a line which corresponds to 32 here. So from this, okay, so we already have this line. So I will draw horizontal. So that is corresponds to 16 now. Okay, so once this is 16, I will draw remaining line as 32. So from this point, draw horizontal. Take the dimensions that is equal to 32. Similarly, draw few more lines horizontal. Dimensions will be again equal to 32. Draw a line again horizontal. Dimensions to be equal to 32. Okay, so this is how the circles which are been drawn. So now let's some of the things which we don't require, I will just trim it out the things. So this is not required for us. This is also not required for us. This is also not required, so I will just trim it out. This is also not required. Okay, so whatever it is required, I will just keep it with us. This one is required, this one required, this circle is also required, this also required, and this is also required. So these are the required circles. So I will just select paste handle here, 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 and last one here. here, out of which I don't want this endpoints, so I will just delete this. They are not required for us. Okay, so the remaining things which is not required, I will just trim it out. This one not required. You can cut it also. Okay, so all this unnecessary things has been cut it out. Now you just go to the extrude operation and just check it out how the object will be. So I will select the direction to be on the other side. So this is the direction vector which okay, direction, will just check it out. So instead of add material, make it slice material. Direction, okay, so let's check the direction. Not okay, this is the required direction, make it apply. So they should be the cells and the all should be if I take it total is 75, so if I take it 67.5 for example, okay, so let's make it apply and generate. So this is how this has been done. There is some water bath also at 65 distance, and it is told that the pipes or the fibers are partially filled, partially in the we can say the water bath. So accordingly, I have put. Next, what I will do, I will just the actually the cells are of dimension 65, so I don't need the additional distance. So accordingly, I will proceed. So make it offset Z. So first of all, I will make it 9 here. So let's make it okay. So let's make it 10 first. So here, so let's make it generate, and then we'll do the slice operation, make it apply. So this is all related to batteries, which is of diameter 65. Then one more plane I will create. Or I will take this first one. Okay, so you can take it offset ZX, make it transform. So let's say offset Z, let's take it 8. So or 8 or 9, whatever the thickness which you are considering, 1 mm as thickness for example. So here it will be. So generate is done, then go with the slice operation, make it apply and then generate. So now this is how they are been generated. So if you want maybe slightly on the lower side, so that also you can be generated. So we have taken the extrude operation which is related to 67.5. I'll put it 70 for example here. So they will be partially filled with the fluid. Now the cell zones are actually here only, and the remaining, this is water bath. So accordingly we have to slightly make some changes in terms of the geometry which we have prepared. So first of all, what I will do, I will the fibers we want it throughout. So we need to select the fibers, we need to keep the fibers as it is. Only thing is cell we don't want at the bottom. So accordingly what I will do, I will just hide these bodies here. Okay, sorry, I will just hide the cells first, remaining I will keep it as it is. Okay, so I just hide the body here, cells are been hidden. Now what is required is I will hide this also, and this in between part also, sorry, not say fiber. Okay, so hide this also. So what will left out is just the uh, so this is also not required. Hide the body. So now it is left with only fibers, so I will select it all, go to create and make it boolean operation, make it unite and generate. So all this has been generated. Okay, this is just your fibers which we are having right now. So I will make it show all bodies now. So here again there are a few things that need to be understood. This is one plate on which the lithium-ion batteries have been kept. So accordingly, one more time I will just hide this body here. I will hide the cells also, which is on the top side. Okay, so hide the cells also. Now this plate and this one will be of same material. This will be a plate, so I will just make it unite. So create boolean, make it unite and generate. So now this will become a plate, and below the plate you'll be having the water present. So what I will do now again, I will select all the fibers here and the top plate, and I will hide the body. So what is left now is only the water. Okay, so create here boolean, make it apply, generate. So this is will be water zone which has been present, and the say fibers, they are actually installed inside. You can select one of the fiber and you can see it is deep inside there. So this is your fluid zone only. So I will select that as a fluid zone and accordingly we'll make some changes. Okay, so this is the air channel which we are having. This is the cell 1 2 3 4 and 5. So I will say form new part here. So rename this as cell. Next I will hide this body. I will hide the cells also. I will hide this zone also. So these are now select all. So this is I will form new part. So this is your fibers. This is your pack. So this is your plate. So I will define this as AL plate. This is your channel through which the fluid is flowing. So I will put it air channel. So this should be fluid air channel. So make it fluid. Okay. So aluminum plate will be solid as it is. So next is this is your water. So it make changes as a fluid. So here you can also put as water also. So this is air channel, this is aluminum, and this is your water. So individually we need to define the cells also. So I will just copy this name and we'll put it name for each and every place. So here cells, this is your cells. Sorry. So next is your again cell, and next again your cell. Okay, so this is now next you have to do is fibers. So make it here control V. So you have to do it for all, make it control V. Okay, so we have mentioned all of them as fiber. So make it show all bodies. Now you can see things are there. So these fibers are partially filled inside the fluid here. Now accordingly we can proceed further. Okay, so geometry preparation has been done. At specific plate, at specific space, we have put the names also. Now it's time to save the work. So we'll save with some different name. So here, so we have total considered 5 cells, 5 cells with fiber. Five lithium cells with fiber for thermal management. So make it copy here and click on save. Okay, just see we have total 5 fibers, 5 cells, and remaining are the fibers. So we have saved the work. So once the work is saved, you can actually close the geometry part and we can proceed. But before proceeding, just observe cell is solid, the fibers are solid, and then water is fluid. Air is solid, air channel is the fluid. So this is the thing which you have to ensure before proceeding for the next step. Now it's time to proceed toward the mesh. Click on edit. So let's open the mesh. Okay, so sometimes if it is not loaded properly, you may have to go and clear generated data if it is not loaded, or if it is showing some error like this. Okay, so I will close this meshing. Okay, sorry, one operation was left. Okay, one more time I will open it. Just check if it is working. So okay, this is now loaded. We can go inside. So let's just generate the default mesh first. We'll see how is the quality of mesh, and accordingly we'll proceed for the different element size. So right now looks to be 5,83,695. So maybe we can go with some 0.005, and let's make it okay. Let's make it generate. So if you are not satisfied with the mesh, you can definitely go with some different size. So I took 0.0005. If you are okay with this, you can go with 0.005 again then. So I will take 125 and I will just proceed with this particular mesh. So 0.00125. Earlier I took 0.005. Now I am taking 10125. So it may be slightly finer than the earlier one which we had. But again, you might not be satisfied with this quality of mesh. So I will put it 0.001 generate mesh. Okay, so you can make it further fine also. So I will take it 0.0005. Yeah, the number of nodes and element will be more, but if your system is capable of doing it, you can definitely go with the finer size of mesh also. Definitely the time requirement will be more. So than whatever the element size which you have taken earlier. So in this case, definitely the time required will be more, and again the number of nodes and element are more. So there may be some more time will be required either for performing the mesh, as well as when you go to the setup. That time also you might see the time requirements are slightly on the higher side. Okay, so this is becoming fine. So we might go with this particular size of mesh which is having, or if you want you can definitely go with some finer size and then this also. So I will definitely go with this only. So we'll just specify the inlets and outlet. So create name selection, I just specify this is inlet. On the other side I will specify this as the outlet. Okay, so inlet outlet has been specified. Go to the geometry, go to the cell and hide all other bodies. So I am selecting the cell surfaces. So create name selection, I will mention this is as a cell boundary. Okay, so show all bodies. If you want you can specify the aluminum plate and other things. So these are all the things can be done. So put it on let us say update. So you will see a message that is the mesh translation to Fluent successful. Once that message appears you can actually proceed for the next step. Okay, so you can see in the mesh translation to Fluent successful. So you can see inlet, this is outlet and this is your cell boundary. So you can now proceed. So you can close the meshing window and now you can proceed to the setup part. So you have to observe in front of the geometry it is right click, in front of the setup mesh is right click, and the mesh window once it is closed you can go to the next step. Okay, so the mesh now has been closed. So first of all save the work, and with the we are done with the mesh. Now it's time to go for setup. So go to the setup. I will go with some more number of processes. So click on start and let's proceed further. So this may take some time to load. Once the object has been loaded you can actually proceed to the next step. Okay, so the object is loaded. Now we'll proceed with the next step. So go to the transient, select the gravity. I will put it minus 9.81. Go to the models, energy equation, you have to turn it on. Viscous, I will put it K epsilon, enhance wall treatment, thermal effect and curvature correction. Let's mark it OK. So next is your materials. So go to the create, go to the Fluent database. So I select water liquid here, make it copy and then close, then close. So we need to go with the different materials which we are having. One is fiber and second one is your aluminum. So aluminum plate is already there. So I will just put it fiber here, fiber. So we just look for the properties. So let's define the fiber material with the density. Again, this is from the reference paper 954, then 1600, then it is 1.21. So make it change create, then make it OK, close. So one more time I will just go to the Fluent database, solid. I will put it aluminum here, make it copy, and then close. Okay, so here I will just put it lithium batteries. So here again chemical formula. Okay, so this is 2775, again from the reference paper which we have used. So this is your 3, make it change create, then close. So here one more time for aluminum plate I need aluminum, so make it copy and then close. So we have water, liquid, air, aluminum, then lithium battery and fiber. So go to the cell zone conditions now. So in cell zone conditions you will be observing the zone types. So air channel, this is your fluid, that is your air. So ensure that this is air material, make it apply, and then close. Water, where it is present, so you must specify in that region. So water, liquid, make it apply. Okay, so aluminum plate, the material should be aluminum. So you just have to ensure that the same material has been selected here, otherwise there will be errors. Cell, we need to put it edit. So here I will say lithium battery source term. Source term, here I will go click on edit, I will make it 1. So here I will put it constant, I will put it 104017. Let's make it OK, make it apply and then close. Okay, so this is next one is your fiber. So fiber material should be the same as what it is defined. So we are done with cell. Ensure one more time, cell is lithium battery, aluminum plate is of aluminum. So these are the material you have to ensure. Now next is boundary conditions. I will go to the inlet. Let's say I put some velocity here as 0.3 meter per second. Make it apply and then let's close. Okay, so cell boundary contact regions are there. Now we need reference, report definition. Go to the new surface report, area weighted average. Here I will say temperature. Here I will put it total temperature. Make it here. So I will say total temperature report definition 0. Make it OK. New surface report, area weighted average. Temperature, I will make it total temperature. Here print to console, I will mention this is cell temperature report definition. Now the report definition I will put it to 1. So I will select cell boundary contact region TRGs and I will select wall cell at the bottom. So make it OK and then close. So report definition is done. Go to the initialization, click on initialize. Once you're done with the initialization, you will go to the calculation activities. Okay, we'll go to the calculation activities, put it 20. Go to the solution animation, new object, contours. So temperature, here I will select total temperature. I will select all. Instead of exponential, I will make it float, make it apply and then close. Click on save display. Click on close, click on contour. Sorry. So I will say total temperature animation 1, make it okay. Now new object, contours, total temperature. I will now select cell boundary contact regions. Okay, ensure that the cell boundary contact regions are been selected. Then I will select the wall cell. Okay, make it close. Now I will put it cell temperature animation. Okay, so make it okay. So one more thing which was left, I will go back to the boundary condition. Ensure that cell boundary contact region has lithium-ion battery. So by default the material should be lithium-ion. If it is not there, you have to change it. Okay, so you have to go with the lithium-ion here. So that is one careful thing you have to do before proceeding. So I will one more time initialize this because the default material was not showing lithium battery. So now I will make it lithium battery here, make it apply, then close. Here also we'll do the same thing. Instead of fiber, select lithium battery, make it apply, and then close, make it apply here. So for region 5 and 6 you have to do the same thing. Ensure this is again lithium battery, make it lithium battery, so make it apply, and last also. So go select lithium and battery, and accordingly you have to proceed. So if this is not selected, then there are chances you are making the errors. So now let's go to the wall fiber. So this material should be by default the fiber. It is there, so no need to change. Wall cell I will make it. Wall cell, you have to see it is lithium ion there. Make it lithium ion. If it is not there, make it apply. Apply. Close. Wall AL plate. So this material should also be aluminum. Make it apply. This close. Okay, so one more time I will do initialization because the material selection was not done. So I will go with the initialization here one more time. Once the initialization is done, you will run on calculation. Okay, cell temperature animation I will just edit it because I am not observing the scale which is float. Make it apply. Earlier the exponential scale was visible. I don't want the exponential scale, so that's why I close this, make it okay. So now it is the float scale which is available. So click on run calculate. I will just run it for first 10 and then accordingly we'll see. So let's click on OK and run the simulation. Till the time you don't run it for around 20 iterations, you will not be able to see all the curves. You will not be able to see the animation windows. So all two curves and two animation windows will be visible in this particular case. So we'll just wait till the iterations are completed. So if you are taking more number of nodes and element, definitely the time requirement will be more. You always check your usage with the computer. So the RAM usage may go higher. Okay, so we have to wait till the first 20 iterations are completed. Once the 20 iterations are completed, you will be able to see colored contours also. You will be able to see the temperature contours also, and you will be in a position to visualize the two curves, that is cell temperature curve and the total temperature of the system curve. So we'll wait till the first iterations are completed, then we'll come back. So we are about to complete the first 10 iterations, first 20 iteration, we can say iterations. For the first time step, we have set it to 10 time steps, and accordingly we'll visualize how it happens with the first iteration. So you can see now the temperature contour has been visible, that is total temperature of system. This will give you the cell temperature. This will give you total temperature, cell temperature report. This will again give you the total temperature of system report. This will show you the scale residual. So the process has started. We can visualize also, but we have to run it further in order to visualize, in order to make some correct meaning out of it. Thank you. So we are at the end of around 900 time steps. So this is the total temperature. This is the total temperature of the system. This is controls of total temperature for cell. This is the cell temperature curve, and this is your total temperature curve. Then this shows the number of iterations which has been performed. So we might have to run this further in order to visualize it in more better way. So this is how the direction is. The figure shows the inlet and outlet for this element. So this represents the scale residual. This represents the cell temperature with respect to the flow time. We are run the simulation only for 120 seconds, so it has to be run further. So that this represents the total temperature of the system with respect to the flow time. This represents the contours of total temperature of cell. You can observe some variations in temperature from inlet to outlet. So this is contours of total temperature of system. This represents the contours of total temperature of cell, how the temperature variations are taking place. So this represents the contours of total temperature of the system.